Hi everyone, today I am explaining by Part1C program 1 for our computer organization and architecture lab 3, and this is the question. Program 1 and loop and add. Figure 1 is illustrate a hexagon figure with the same length of side. To calculate the perimeter of the hexagon, and the following formula is given. The hexagon which have the 6 side, and we have to calculate the perimeter hexagon 1 and perimeter hexagon 2 and total perimeter. We have to write a complete program using assembly language to calculate the perimeter of the two different hexagons with different sizes. In the program, you should do this step. Get two values from the keyboard and save into variable name side x1 and side x2 for the both hexagon. Calculate both of the perimeter by using loop and add instruction, and save the first result in perimeter hexagon. Then add the two perimeter and save in total perimeter variable. Display the output shown in it. This question asks us to calculate the perimeter of the two hexagons with a different side of the lens and get two unsigned integer output from the input from the user. Calculate each hexagon perimeter by adding the side 6 times and then sum both perimeter together, and finally display the perimeter and total perimeter exactly matching the given sample output. This program must use the loop and add instruction to show how iteration works in assembly. Let's look at the program code line by line. First, I start with comments at the top of the describe the file, which is hexagon perimeter and ASM file. Calculate the perimeter. These comments explain what my program does, which help others understand my code. And then I include the Iwin library as usual to useful high-level procedure like write string, read deck, and write deck, so I don't have to write everything from the scratch. And then the data section, I declare all the text messages I need. Here the message one is my main title message, which I displayed at start. The 0D and 0A makes sure the cursor goes to the new line after. And then message 2 and message 3 are the prompts asking the user to enter the first and second hexagon side lengths. And then the message 4 and message 5 are the labels I display when showing calculate the results. And I also declare to store the input value and calculation part, which is side x1 and side x2 and perimeter 2 and total perimeter. Each of these is a 32-bit dword variable initialized with question mark, meaning they are uninitialized at program start. And then code section, I begin the main procedure. This is the mark start of the main program code. And first I clear the console screen and display the title, which I call the clear the screen, and move edx and offset message on. Load the address of my title message into edx, and then I call display the message, and then I move the cursor to new line. Then I prompt the first hexagon side length, which I display the first message. I display the second message and read the decimal number entered by the user and store it in EX. Then I move EX into my variable side x1. For the second hexagon, I repeat the same process. I display the message 3 and read the second input with the read decimal number entered by the user and storing the result in EAX. And then later I save the value in side x2. Now I calculate the perimeter of the first hexagon using the loop. The move EX as 6 set up to a loop counter for 6 sides, and the move EX 0 initialize the accumulator to 0. In the loop label L1 and add EX in side X, which add the side length to the running router. And the loop 1 decrements ECX and repeat until ECX reaches 0. After the loop finishes, EX contains the perimeter of the first hexagon, which I store in perimeter 1. I do the same for the second hexagon with the second loop. Again set the EX to the 6 and clear EX to the start from 0. The loop label L2 adds side X 6 times. After the loop, EX contains the perimeter of the second hexagon safe in perimeter 2. Next, I calculate the total perimeter by adding both perimeter together. Move EAX perimeter 1 and add EAX perimeter 2. Move the perimeter 1 to the EAX, then add perimeter 2 and store the final result in total perimeter. To display the result, I show the header, which I call the CRLF, and move EDX offset message for and call write sync, and it's print the new line and show the result second title. Then I print the first parameter and load parameter into EAX and display with it the right decimal. Then I print the second parameter as usual like the first one, and it's display the parameter 2. And finally I print the total parameter with its label, show message 5 as the label and display the total parameter value. And at the end of the program I exit cleanly and marks the end of the main procedure, and end main tells the assembler where the program entry point is. Alright, now I'm going to test my program using the same inputs shown in the sample output, which are 21 for the first hexagon and 32 for the second hexagon. Before I do the run, I'll build the solution. Here I show build 06, 1 succeed and 0 failed, and then I do the start debugging and the screens come up. And it's first display the title, calculate the perimeter to hexagon loop and add instruction, and the next it's from the input hexagon 1 site line. So I type here 21 and press enter, and it's asked the hexagon 2 input and I press 32. After entering both site length, the program calculates each parameter by adding the site length 6 times using the loop. Then it adds the port parameter together. The program then displays the output exactly like this. The first line says the result of the parameter hexagon 1 and 2. This indicates the program is now showing the result of the calculation. The next line shows the 126, which is perimeter of the first hexagon. Since the first site length was 21, multiplying 21 by 6 site gives 126. And the next line shows the 192, which is perimeter of the second hexagon. Since the second site length was 32, multiplying 32 by 6 site gives us the 192. The final line shows the perimeter of the hexagon 1 and 2, which is 318, which is total perimeter of the both hexagon combined. This is because 126 plus 36 equals to 139. So by entering 21, 32, my program correctly calculate each parameter using loops and addition, then sum up, and finally display the output exactly as shown in the sample output. This proves that my program works as required. Thank you for watching my demonstration.